Why, good day, people. We are on page 88, and we're in section 6.2. So I skipped the first page of it because I don't like that example. We don't see that one too much. I don't want to spend too much time on it. So really what we're going to do is continue to do the same things that we have been with the graphs and finding domain and range, but we're just going to look at what they call as more complex graphs. There's really not, I wouldn't say complexity to it. It's just being careful as to, or showing more options for domain and range, which we talked about already. So when we're looking at this function here, we have a parabola. We're going to deal a lot with parabolas second semester. They're things that have x squared in it. And you don't need to know right now that even how to graph it. We're going to give you the pictures. We're just going to be focused on right now what's the domain, the range, the y-intercept, and then these absolute to relative mins or absolute and relative maximums. So to start off with domain and range. Domain, as a reminder, is always what are our x values. So when I look at this graph, I'm trying to think, does it start anywhere first off on the x-axis? No, because these arrows mean it goes on forever, which is a Sandlot reference. If you haven't seen that movie, you need to see it. So that means it doesn't have a starting and ending point. So when I'm looking at it, I'm thinking that, okay, yes, it looks like they're pointing more down, but x is left and right. Will it continue to go left and right as it goes down? Yes. What does that mean? That our domain is all real numbers. Now, that's the symbol for it. That was not a great one of it, but it's basically a line, two lines, and then you make an R with it. So if you want to shorten it up, that means though all real numbers. So if you're in a multiple choice scenario, know that that's what we would say with it is all real numbers. Now, the range always goes with our y or vertical values. So when I'm looking at the y values, I'm looking, does it have a starting point or a high point? Yeah, it does, right here at 9. So it's not the starting point you would say of the graph, but for the y values it is. It's the highest y value. Now, where do they go after that? My question is usually, does it go up or down? Well, in this case, it goes down. How far does it go down? Forever. Now, that doesn't mean it's all real numbers, because that would mean it's everything, positive and negative, even above 9. But this graph doesn't go above 9. So how do we write that? This is where inequalities come in. So when I'm looking at it here, I know I have something with y and 9. But where does this go again? Down. Down is less than. Does it equal 9? Yeah, at that one spot. So my range would be y is less than or equal to 9. Okay, next up, identify the y-intercept. Now, the other day we said with the y-intercept, the x value is always 0, because on the y-axis, x is always 0. So I'm just going up and I'm looking, where does it cross the x-axis? Well, it crosses at 8. So 0, 8 is my y-intercept. Okay, relative or absolute minimums. Well, let's just look. Does it have a spot that is a low point? No, why not? It goes down forever. You're going to be sick of me saying it by the end of that, but that's okay. It goes down forever. So there is no absolute minimum of this function. So I could just put in none. Now, is there an absolute maximum? Yes. It has a high point that is 9. That's the highest this graph goes. It does not go any higher. It goes to 9, and that is it. Okay? All right. Let's go to page 89. They have a similar one with just a straight line as a graph. They give the equation. Eventually, that'll be helpful, but right now, we just need to look at the line. So again, I'm thinking first domain. Does this go left or right, or have a starting point left or right? No, it's got those arrows on it, which means forever. So if it goes left and right forever, my domain is all real numbers. Then I look at range as up and down. So I put the last time X's for domain. You could think left, right. For range, I could think up, down. How far does this have a starting point for up or down or high or low? No. It goes up forever and down forever. So what's the range? All real numbers. This one, and this is something I would jot down, for a linear equation or function, okay, that is continuous, it goes on forever, the domain and range are always all real numbers. So if it's just a general linear function, just a straight line, and it goes up, down, left, right, like it's a normal one, not a completely horizontal or vertical, it'll always be all real numbers. All right, y-intercept. Y-intercept, I'm going to want to put with a 0 first always, and then I'm looking where does it cross the y-axis? Well, at -1, so my y-intercept is 0, -1. Now, unlike the other one, does this one have an absolute min or max? No, because it doesn't have that high or low point. It goes forever up and forever down. So it's just showing the questions aren't changing. We're just seeing more possibilities in our answers. All right, in number 3 on the bottom of page 89 here, now we see what we call an exponential function. Ones we'll deal with again more later in the semester, or really going into the next semester. But I'm looking domain. So domain is left, right. So I'm looking, how far left does this go? Forever. How far right does it go? Even though it's going upwards, it's still going to go right forever. So if it's left and right forever, it's all real numbers. Now, the range portion of it is where we have to be careful. This is going up forever, but it's going down and it's flattening out as we continue to go along here. It's actually what we would say is approaching 0. It's going to get closer and closer and closer to 0. If you did plug in numbers for x here, and you did like 2 to the -20th, it's going to be a number really close to 0. And it's just going to keep getting smaller and smaller. So our range here, it kind of has a minimum point. And when I say kind of, it doesn't ever equal 0, but it will always be above 0. So the range, because it's going upwards, is y is greater than 0. Okay? Not or equal to. So that's the important part. With exponential functions, okay, your range will always be a greater than or less than. Never no or equal to's that are in there. Okay? Last part that we've seen coming up each time, what's the y-intercept? Well, 0 is always the x. In this case, it goes to 1. Okay? Questions? I don't know, because you're not there. Sad. Going to C and D on the next page, does it have any relative or absolute min or relative or absolute max? No, because it continues to approach 0, so it never gets to 0. It's going to get really close, but it never actually gets there. Okay, lastly here, let's look at just a couple more going to page 91. Okay, so we're skipping a page in there. So here we have another quadratic function, and these are the 3 things that it asks for in number 8. Give the domain, range, domain, range, y-intercept, sorry. So the domain, left and right. For a parabola, it goes forever left and right. Even though it's going up, forever in both directions is all real numbers, whether that's left, right, or up, down. Now the range, it's going forever up, but it has a low point or a minimum. So when we go to absolute minimums, I could look and say, oh, I know that already. It's -3. Well, that goes right in with my range. Now, is the rest of the graph or numbers above -3 or below? Well, it's above. What's above? Greater than, and in this case, or equal to, because it actually equals -3. And then what's the y-intercept? Well, in this case, that -3 keeps popping up. 0, -3. Okay, does it have an absolute max? No, because it keeps on going forever. All right, last one we want to look at is, I'm going to ask us to find, even though it talks about explain why one has an absolute min and max and the other doesn't. Well, these have dots, meaning that's a starting and stopping point. These have arrows, mean it goes on forever. But I want to look at the difference between the domain and range of each of these. Because the domain here actually does have a starting point at -5 and an ending point at 8. It doesn't keep on going forever up and down like this one. So this is where those inequalities come into play, where I have, all right, -5 is the low, 8 is the high. They're closed circles, so it's or equal to. So I'd have -8 is less than or equal to x is less than or equal to 8. The range, same idea here. I have a low point and I have a high point, or a max and a min, in this case -8 and 5. Because it's the range, I have y values, so I put y in the middle. -8 is less than or equal to y is less than or equal to 5. Compared to here, my domain, it goes forever left and right, so it's all real numbers. My range goes forever up and down, so it's all real numbers. So going back to that other statement I said, if it's a linear function that goes on forever, domain and range are always all real numbers. If they have stopping and ending points, that changes what it is. So as we look through these, it was all examples today, but the whole idea was we have lots of possibilities for domain and range. It's not just going to be sets of numbers like the first time we did it every time. In fact, we're going to see that the least amount, 2, 3, 4, 5. Okay, it's not going to be all real numbers every time. Now that we know that, everybody, or not everybody, people often go to just like, oh, it's all real numbers, and you think you're done. Well, what if it stops and starts at certain points? Then we have to decide where is that stopping and starting point for domain and range. So just remember, domains, x's values. Where does it go left and right? Does it have a starting and stopping point? Does it go forever? Range values, up and down. Does it have a start and stopping point, or does it go on forever, maybe in one direction or both directions? So those are really the questions that we're asking as we go through this. Have a great day.